Hey everyone, this is the Math Nexus, and today we are going to continue with exercise 2.3 in the previous lecture. We had done question 1, A, B, and C. We're going to continue for now. So let's jump in for question 1, part D. We're going to start with part D. So we have y is equals to x squared minus 2x minus 8. Of course, this is a modulus graph, and again, I'm going to repeat because it's really important. Um, you have to visualize what your graph is going to look like. Okay, so first of all, we know this is a quadratic equation. It's going to give us a parabola. We know that. Then what we do, we know it's in a modulus, so the values which are below the x-axis are going to be reflected back. We're going to make this something like a dotted line, and they're going to be reflected back up here. So we know that most of the graphs should look like something like this. Okay, that's our basic graph here. So it's really important for us to know what type of graph we are going to get, because that allows us to plot the coordinates and even sketch the graph without any other tension in our minds. So for now, what we're going to do is y is equals to x squared minus 2x minus 8. Again, we need three things for now: the x coordinates, the y coordinates, and the midpoint of the x coordinates. So when y is equals to 0, we are going to get the x-axis values, or you can say when the two points on the graph which are, you know, uh, clashing with the x-axis. So yeah, what we do is x squared minus 2x minus 8 is equals to 0. Again, I'm going to use my calculator to solve this quadratic equation. We have done in the previous chapters how to solve these equations with 3 steps: the quadratic formula you want, the completing the square method, or um, the factorizing method, whatever you find easy. So for now, I'm going to go with the calculator: 1 minus 2 and negative 8. You're going to get x is equals to 4 and x is equals to negative 2. So we have two values for x. What next we are going to do is find when x is equals to 0, what's the value of y? Y is equals to 0 minus 0 minus 8, if I'm not wrong. Yes. So again, we have the two values. We have to find the midpoint on the x-axis to find the x value of the stationary point of the x values. So it's going to be a plus b, so negative 8. Oh, sorry, really sorry about that. Negative 2 plus 4 divided by 2, that's going to be positive 1. And again, we have positive 1 as the x value. How to find the y value? Input the x value into the quadratic equation. So when x is equals to 1, y is equals to 1 minus 2 minus 8. So it's going to be 1 minus 10, which will become minus 9. So 1 and negative 9 is going to be our stationary point coordinate. Let me make it here. So we have our graph here. What we're going to do is plot our points. So when x equals to negative 2 and 4, y is equals to 0, negative 2 and 4, like this, and like this. To zoom out, I guess. And what we have is y is equals to negative 8 when x equals to 0. I think I have to extend my graph for now. Yes, I have the freehand to do something like at this point it's going to be negative 8. Yeah, 1, 2. Yeah. So another point is going to come here, and I think we have to further extend the graph. Let me just make a line here. Wait a second. And negative 9. Okay. So now what we do is plot the other point. If I'm not wrong, it's negative 1, 9. Sorry, positive 1, 9. When x equals to positive 1, y is equals to negative 9. Another point here. And that's it. Yeah, these are the points. Negative 1, 9, 4, 2. 1, 2, 3, 4. Yes. What I would prefer is, however, take when x equals to 3, so I could have an extension of the graph. When x equals to 3, y is equals to is a 9 minus 3 to 6 minus 8. So y is equals to minus 6 minus 8, which is going to become minus 14. And we are going to add in 9. So we are going to get negative 5, if I'm not wrong. Let me check this out. So x equals to positive 3 is equals to negative 5. Positive 3, negative 5. Yeah, another point is just going to help us draw a more detailed graph. I think it's not so necessary right now. So I'll just make it with this one. And if we just go, we have some extension in the back, like so. And we're going to extend this one in a similar way. And that's it. So this is only our first part. What we need is to reflect this graph up. So we had another a point at negative 8. So switch that point to positive 8 because it's a modulus. And the other point is at 1. And the negative y value will change into positive. So the second point will become here. So we add a curve, we pass it through this point, make it so that it's matching the one we have made earlier. Like this. And that's it. Okay. And we can obviously extend the graph if we want. For example, when actually I had to insert negative 3, not positive 3 actually. Let me just see. If it's a big value, then I'm going to leave it. X equals to negative 3 and negative 3 squared minus, in fact, it will become positive 6 minus 8. So which is a 9 plus 6 minus 8. And that's going to be 9 plus 6, 15, and 15 minus 8 is going to be 7. So y is equal to 7. Yeah, 7 is not a bad value, so I'm going to add it. So here, negative 3 and 7. It's going to make a line up. 3 and 7, something like this. Yes, I'm good. So that's it. In fact, I'm going to do the same for here, one box. And that. And that's it. So this is a graph for question number 1, part D. Okay, now proceeding on to part E. Oh, now for part E, we have y is equals to 2x squared minus 11x minus 6. And what we do next is, first of all, input when y is equals to 0, because we have to find out the points on the x-axis, which are obviously clashing with the curve. So 2x squared minus 11x minus 6 is equals to 0. We're not going to concentrate more on the quadratic formula. Just going to input this into the calculator. Minus 11 and minus 6. And that's going to give us 6 and negative 1 upon 2. X equals to 6 and x equals to negative 1 upon 2, which means actually negative 0.5. Okay, for the other value, we have to find when x is equals to 0. When x equals to 0, y is equals to 0 minus 0, minus 6. Second value. And then we have to find the midpoint. So midpoint is negative 1 upon 2 plus 6 divided by 2. So that's going to be 6 minus 0.5 is 5.5 divided by 2. And that's going to be, let me see this. And that's going to be 2.75. Okay, 2.75 when x is equals to 2.75. 2.75, sorry, not 2.25. So what's going to be the y value? It's going to be 2.75 squared 2.75 squared multiplied by 2, you're going to get 15.125. 15.125 minus 11 multiplied by 2.75 is going to be 30.25 minus 6. That's going to give us minus 6, sorry, plus 6.25 and minus answer 36.25 plus 15.125. That's going to give us negative 21.125. Yeah. So we have our value for the stationary point, which is 2.75 and negative 21.125 to be specific. What we are going to do is draw this on a graph. However, let me just clear this up first. Okay, so we have drawn a graph. What I'm going to do is plot my points. So negative 0.5 is going to be at this point. We can do negative 0.5 at this point, and the other point is at 6, positive 6 here. Then we have when x equals to 0, y equals to negative 6. And that's going to be at this point, if I'm not wrong. Then we have a midpoint at 2.75 and minus 21.125. So minus 21.125 is going to be at this point, 21.125, something like here. And then we have 2.75. So, and it's going to be somewhere approximately here. Wait a second. 21.125. That's 21. Somewhere here. Okay. That's it. We now need a curve to connect our graph. We're going to go all the way down here. Safety. Can it fit in the range? Yeah, it's fitting. So it's going to connect with these points. Yes, that's good enough. And then that's it. Okay. The next thing what we'll do is we're going to reflect this graph. So negative 21.25 will become positive 22.25, and that will give us a point that will be approximately 20.21.25. That's it. And which point did we have? 2.75. Yes. So 2 and 0.75 is going to be somewhere like here. Why is it? Oh, I think I have to reload this. Oh man, I always do this mistake. So what we are going to do next is take this negative 21.125 and connect with this 2.75, and that's it. Then where did we have? Yeah, so it's positive 6, another point, and then we are going to connect this with our curve. Oops, that's too much. Let me just Now what I'm going to do is Control Z, and I'm going to connect this up, this one here, like this, At this point, I'm going to take it all the way down here. And that's it. This is our graph for part E, if I'm not wrong, yes. And the thing is, you can also plot another point. For example, you can say when x is equals to -2, when x is equals to -2, we have um, -2 squared, which is 4, 4 to the 8, which will minus 11 to the positive 22 minus 6. That will become 8 plus 22 minus 6. That is 24. Do I have 24? Yes. So I'm going to just take it up here and connect a line with this. Something like that. And that's it. Same for the other one. And -8, yes. And that's it. Oops. Sorry. I need this one. This. Okay, so this is our graph for part E. And I know that the graph process is really, a little bit boring, I would say, really for me also. So I'm really sorry if I'm a bit silent between the graph making part because I'm trying to concentrate for that. For part F, we have y is equals to 3x squared plus 5x minus 2. What we are going to do is assume when y is equals to 0, we have to find the x coordinates at the x-axis. So that's going to give us 3x squared plus 5x minus 2 is equals to 0. If you do not know how to solve a quadratic equation, take my previous lectures. I'm going to use a calculator. So 3x squared plus 5x minus 2, that's going to give us 1 upon 3 and -2. So x equals to 1 upon 3 and x equals to -2. So again, similarly, we have to find the y coordinate when x is equals to 0. That's going to give us 0 plus 0 minus 2 is equal to 1. Again, find the midpoint so that we can find the stationary x value. And -2 plus 1 upon 3 divided by 2. I'm going to solve this directly with the calculator. -2 plus 1 upon 3 divided by 2, that's going to give us -5 upon 6. -5 upon 6 is actually equals to -0.83. Okay. And for, oops, I'm really sorry. That was my stylus. So when x is equals to -0.8, or in fact, you could just write the fraction form because it's much more accurate. -5 upon 6. So y is equals to 3 multiplied by -5 upon 6 squared plus 5 multiplied by 5 upon 6 minus 2. Okay, so that will become 3 multiplied by 25 upon 36 plus 25 upon 6 minus 2. That's going to be 3 1s are 3, 3 1s are 3, 2 to 6, 25 upon 12. Wait a second, 25 upon 12 plus 25 upon 6 and minus 2. That's going to be 17 upon 4. Okay, 17 upon 4. And if you want to give this a decimal form, we are going to get 4.25. So we have a coordinate stationary point at -5 upon 6, comma 4.25. Okay. Okay, so the thing is, I've done my plotted my points on the graph, and another thing I wanted to tell you is I took +5 upon 6, where however it was -5 upon 6. So it's going to change the y value. It's going to be -49 upon 12, which is approximately -4.08. So I plotted these points on the graph. What I'm going to do is connect them with a curve real quick. I'm going to come here, over here. Wait a second. Before I do this one, I think this side would be more efficient. something like this. And similarly, no, it's not looking good. Like this. This is good enough. And that's it. So this is the first part of the graph. What I'm going to take is, in the side, I'm going to take when x is equals to, I would say, -4. I'll take when x equals to -4, y is equals to -4 squared, -4 squared, multiplied by 3, which is 48. 48 plus 5 multiplied by 4 is 20. So it's going to be -20 minus 2. Okay. So that's going to give us positive 26. Oh, wait a second. I'm not wrong. But it's not -20. Wait a second. I think I've done something wrong. So 3 multiplied by -4 squared is going to be multiplied by positive 4 squared actually, because it's 16 multiplied by 4 is 64 plus 5 multiplied by -4 minus 2. That's going to be 64 minus 5 4s are 20. And oh yeah, 64, we have to multiply 64. I think I've done a mistake. Yes, 16 multiplied by 3. Yes. Okay, my bad. I'm really sorry for that. 16 multiplied by 3 is going to be 48. 48 minus 20. Because 5 4 is just 20. Minus 2. If I'm not wrong, yes. And then similarly, what we are going to say is 48 minus 20 minus 2. That's going to be 26. Whatever it's a big value. I'm going to take when x equals to -3. It's much more better for now. I'm going to take when x equals to -3. -3 squared is 9. 9 multiplied by 3 is going to be 47. 47 plus 5 is 15. 27 minus 15 minus 2 is going to be 10. So when x equals to -3, y is equals to 10. So I'm going to take this value, -3, and go all the way up here. 7 and -3 and 10. I think it's enough if I just connect this up with a line. And that's it. What I'm going to do now is reflect this part of the graph above. So it's going to be somewhere, if I'm not wrong, 0.025. Let me just check the coordinate again. 4.08 and 0.8. It's going to be here. Somewhere. So again, I'm going to use the curve tool, connect these points up, thing like this. And this is it. And this is the graph for the other point. I'm going to take 10 and then connect this. I think I'm done something wrong. Let me check when x, I think I need when x equals to 1. I also need when x equals to 1 to make a good graph. So when x equals to 1, we have y is equals to 3 plus 5 minus 2. Y is equals to 3 plus 5 is 6, 7, 8. And 8 minus 2 is equals to 6. So y is equals to 6. Extend this graph to 6 and 1 here. So I'm going to draw a line and connect. So that's it. This is our graph. Let me just zoom out a little bit, and that's it. This is our graph for question number 1, part E. And This was a short lecture, but the thing is, I'm going to continue with the rest of the questions in the next lecture. So wait for the next lecture. I'll meet you there. Thank you.